Everyone, this video is just to add to our previous recording talking about the chi-squared test in biology. We're testing for association between this flower here, gazania, and this one here, sunflower. Now, first of all, let me explain what association is. Association means that if you go into the field where these flowers are growing, wherever you find sunflower, you're most likely to find gazania. If that's happening every time you find a sunflower, you find gazania next to it or close by, then there's an association. Whereas if you find a sunflower and you don't find this sometimes and other times you do find it and there's no special relationship, then there's no association. Then there could be another type of association, what we call a negative association, where once you find a sunflower, it's quite likely that you would not find gazania. They have a tendency to never be together. That's an association, but a negative association. So there are three outcomes that you can have in this investigation. One, of course, which is association, being positive association, these two found together. Negative association, never found together, and no association, which means that you find this, sometimes you find this, other times you don't. No special relationship. Now, to go about establishing this, we need to go out into the field and examine the distribution of these plants out in the field. A good tool to use to carry out that type of investigation is the quadrat. Here I spoke about a 1 square meter quadrat, and the quadrat is laid out at random. So what we have to do is to imagine that the area that we're investigating, we don't literally put a grid over it like this, but we imagine that it's made up of a grid, an x-axis here and a y-axis here, and then we use a random number generator to generate x coordinates and y coordinates. And for instance, you get like 10 here and 4 there, and you put your quadrat here and you take a note of what you have, and you take about 20 samples at least, because this statistical test won't be valid unless you take 20 plus samples, more than 20. And then each time that you put out the quadrat and you collect data, you decide which of these 4 boxes to put your check into for the 20 trials that you do. And then you fill out this entire table. Then, using this table of observed values, we calculate the expected values using this relationship here, row total divided by combined total multiplied by column total. So here for this example here, for instance, the row total is 12 divided by the combined total, which is 25, multiplied by the column total, which is 6 for this column here, and that comes to 2.88. Then we also need to calculate the degrees of freedom for the chi-squared test. Using this formula here, we realize that the degree of freedom that we are dealing with in this calculation is 1. Then, with the observed value calculated for all of the 4 boxes and the expected value calculated, we can plug everything into this table and then take the sum here of all of these values. That is chi-squared. So now that we've got chi-squared and we know that the degree of freedom is 1, then we go to this table here of critical values and degree of freedom 1, and we search for where our chi-squared value would be. And our chi-squared value is 0.0127. So that would fit somewhere right around here. 0.016, 0.0127 would fit somewhere around about here. And that corresponds to a p-value, which is really the probability. The probability of this particular data set occurring is more than 90% likely. It's between 0.9 and 0.97. So it's well over 90% chance that if you went into your field and you took samples, that you would get this. And when you have something that is like 95% likely to happen, it means it's not special, and there's no special association or lack of association. In fact, there's no association in this particular study between the two plants. So again, here we show that the outcome is more than 90% likely, just taking this little section of the table out. And if it's very, very likely that you would get this outcome, it means that you don't need any special circumstances, it doesn't show anything special, then there's no association, and we take H subscript O, which stands for the null hypothesis. We accept the null hypothesis. To accept the alternate hypothesis, which is to say that there is a positive or a negative association, that would mean that chi-squared would have to come somewhere all the way down here, less than 0.05, with a p-value less than 0.05. So chi-squared would have had to be somewhere between your 3.8 and 5, which is quite a high value for chi-squared. And when you get that kind of value, and you have the 1 degree of freedom, it falls below this. Scientific convention then says that there's only a 5% chance of this thing happening, which means we have to look at it closely and say, it's likely that this could be some kind of association. And you can say with a fair amount of confidence, when you get your value somewhere around here, that there is an association. And when you get values way up here, you can certainly say with a lot of confidence that there's no association. So this then is how you would interpret the meaning of the p-value.